Hello YouTube, Mr. Eclectic here. Today I'm making a sequel to Lexi's video on the smart planter that we designed together. This project was a true 50-50 collaboration. Lexi owned the visual design aesthetic and the physical case, while I focused on the technical engineering aspects, which I'm going to be covering in this video. Lexi has developed a green thumb. Not only does she enjoy growing plants, but she has like an emotional attachment to them. She's even given names, I think, to all of our plants. And from my side, I have a real absence of emotion when I think about modern tech devices. I love technology, and yet I rarely get excited about any tech hardware. So I think these two ideas came together to inspire the planter that we ended up creating. We built a planter that physically houses a plant, but also has a display which shows measurements of the current soil temperature, moisture level, light illuminance, and conductivity. Why would we care about conductivity? Honestly, I don't know. Supposedly it has to do with plant fertility, but don't quote me on that. I wanted a device that was not on the internet. I didn't want our planter to be talking to remote cloud servers, and this is not just to protect our privacy, although it is, but also we don't have to worry about a company turning off their service and now suddenly one day our planter doesn't work. We know basically until the internal components die, this thing is going to keep running. Also, I didn't want to have to worry about hackers getting access to our home network via our planter because it wasn't 100% secure in some way. Finally, I didn't want the planter to be sending my phone push notifications when things got low or whatever, which seems like a feature any other planter would have, but any other smart planter, that is. But if I want to know how the plant is doing, I have to actually go into the room and look at it. And in my opinion, this is a feature, not a bug. I think it keeps me more present and more in the moment. And it gives me that, even though it's leveraging technology, it's also very much dependent upon being in that physical space and being there physically with the plant. I wanted as much as possible for the software that we use to be open source. This is for two main reasons. First, anyone with compatible hardware would be able to download the code and run it at home for free. Second, if something is not working with the system, any user who knows how to program can read any of the code, figure out what the problem is, and fix it for themselves. They don't have to rely on some company to fix it for them. This is something that really annoys me. The first thing you'll need is a Raspberry Pi 4. It technically doesn't need to be a Raspberry Pi 4, but the Home Assistant website does warn that you need 2 gigabytes of RAM to use their software stack, so make sure you have at least that. And if you've never used a Raspberry Pi before, note that you will probably need to purchase additional accessories unless you buy a kit that includes all of them. In particular, I recommend getting an official Raspberry Pi power supply and a good quality SD card because most of the times I've had issues with the hardware not working, it had to do with either using a cheap power supply or a poor quality SD card. Next, you're going to need an 800 by 480 LCD screen. You can use a screen with different dimensions if you like, or if you just have an extra one lying around. However, you'll have to make a small code change for the UI because I hard-coded in the dimensions of the screen into that. Probably most importantly, you're going to need a Bluetooth plant sensor. Unfortunately, I couldn't find any more information or branding for the one that we used, but I will include an Amazon link in the video description to the one that we got. And finally, a 3D printed planter. See Lexi's previous video for more information on that. Although we had casually discussed making some kind of product together that could take plant measurements. I think this project really started when I found an online article that described the open source home assistant platform. From their website, their tagline is, "Open source home automation that puts local control and privacy first. Powered by a worldwide community of tinkerers and DIY enthusiasts." So Home Assistant is a collection of software that knows how to talk to many different smart devices, and then it can present all that data together in a single dashboard. It's also something that you can run locally on hardware that you control. It doesn't need to run on the cloud. Once I realized that this project existed, I could see a way for us to build the kind of unwired open source planter that fit with my own tech philosophy. It wasn't a perfect fit, however. The Home Assistant platform's architecture is serverless. What does this mean? Well, usually when you think of a computer, you probably think of it being connected to a monitor and a keyboard and mouse, or a touchscreen, like your phone or tablet. However, there's another category of computers, they're usually servers, that we call headless because they're not hooked up to a monitor and they're not they don't have any kind of graphical display, and they're really only intended to be accessed via a network. So they usually have an Ethernet cable plugged in. And that's the architecture for Home Assistant OS. It has a built-in web server, and so the idea is that you're gonna install Home Assistant on a Raspberry Pi or some other device that you're gonna run, and it's gonna be connected to your home network. And then if you want to then view the data from your Home Assistant, you're going to have to connect to it from one of your other devices like a laptop or your phone on your home network. This posed a technical problem for us because we wanted our device to be self-contained. We wanted the code that rendered the display to be running on the same device that was communicating with the sensor. We didn't want to have to embed two Raspberry Pis in our planter. This meant that we couldn't use the Home Assistant's recommended installation method, which was just flashing Home Assistant OS on our Raspberry Pi's SD card, because Home Assistant OS didn't have the necessary graphical capabilities that we wanted. Instead, I installed Raspberry Pi OS on our device, then I ran the Home Assistant platform within a Docker container. Although this is an officially supported option, it doesn't support running third-party Home Assistant plugins. Fortunately for us, though, Home Assistant supports our sensor out of the box, so we didn't need to install any plugins. Since Raspberry Pi OS comes with a display server built in, we had almost everything we needed to glue all our components together. I planned to write my own UI software from scratch, so the last thing I needed was to figure out how to get the data from the Home Assistant Docker container into my UI program. After too long digging through documentation, I finally found out that the Home Assistant comes with a RESTful API server. If you don't know what an API server is, it's like a regular web server, except instead of serving HTML and JavaScript to a web browser like Chrome or Safari, it sends machine-readable data called JSON directly to custom programs that were written specifically to process that data. And this is what I was doing. I was writing a custom program that would read the JSON data about my plant from Home Assistant and then render a custom UI onto my physical display. The first thing that went wrong was we realized that the ideal physical orientation of the screen would have the display flipped. If we rotated both the display and the Pi, now the power cable would be in an awkward position. And if we tried rotating only the display and not the Pi, none of the ribbon cables that we had for connecting the two would be long enough. While Lexi considered ordering a longer cable, I suggested the laziest fix. Let's just flip it in software. While I knew that you could rotate the display via a Raspberry Pi boot configuration, this wasn't working for me, and a Google search for the error suggested that I would have to change the video mode, and I was worried that that was going to hinder our graphical performance. So again, I went with the laziest fix. Since we're using a display server to render our graphical user interface, let's just rotate everything vertically in our display server config. This means that when the device first boots into text-only mode, the text is upside down, but other than that, everything's fine. Next, Lexi noticed that the screen in the case was getting warm. This was a concern both because we didn't want the heat to harm the plant or the 3D printed PLA. To address this, Lexi purchased a small fan which was able to draw power directly from two of the Raspberry Pi's GPIO pins. And I changed the UI software to go from rendering at 30 frames per second to only redrawing the screen when there was new data from the sensor. With these two changes, the heat generated was significantly less. While I was at it, I updated the UI software to show the Raspberry Pi's CPU temperature. That way we could monitor it. So that's how we made the Plantador. Overall, I'm really happy with how it turned out. It lives in the hallway between our bedroom and our office, and every time I walk by, it makes me smile. The case design is fun, the UI aesthetic makes me feel like a kid playing around with BASIC, and I find myself more interested in the well-being of that plant than any of our others. Finally, I feel like we stayed true to our goals in designing this product. For the future, we both would love to make this a self-watering planter. This would mean figuring out how pumps work and then how to hook them up to a Raspberry Pi. But then we wouldn't have to worry about our plants when we go on vacation. Also, don't forget that we're both going to be at the Open Source exhibition on July 18th through 20th of this year in the San Francisco Bay Area. I'm really looking forward to going and seeing all the cool projects everyone else has been up to since last year. I may continue to tinker with the Plantador UI to make it more interactive and/or animated for people to play with at Open Source. Please like and subscribe. Thanks for watching.